Hey, welcome to Chapter 2. This chapter, as it says right here, is using algebra to explain. We can use it, as we saw in Hannah's video early on, to make sense of the world. And really, this is a chance to find some math that allows us to do that. The contents are listed here. We're going to be going through all 8 of the lessons. You'll be continuing with the mastery learning process. The first thing to do in starting up this chapter is to read the chapter opener. This one's kind of cool because it teaches you a card trick, and then later on we'll look to explain it with algebra. If you can figure it out yourself, that'd be great. Try to see whether you can make an equation that makes sense given the problem and see how come it works the way it does. So read through the chapter opener. When you're done with that, we'll take a look at the 2-1 and we'll get started with the lesson. Okay, let's take a look at lesson 2-1, but I want to do a couple things with you first. I want you to try looking at some problems and see how we might find an easy way to do some multiplications. This is a mental math kind of thing. So let's say I'd like to multiply a number by 21. So I'm 21 times, let's just say 5. And I can use the distributive property, which we're going to get into, but I can change this into a multiplication problem that would be easier for me to figure out by simply making this 5 times 20 plus 1. 20 plus 1 is 21, and 5 times that. And 5 times 20 is 100, plus 5, 105. I found myself a way to kind of quickly take a problem that might be a little bit more difficult to do and see how I could get my result with it. Let's take something a little bit more difficult, and let's try 85 times 21 and see if it'll work there. So we get 85 times 20 plus 1, and so we get 85 times 20, that'll be 1700, and 85 times 1, well, that's easy, that's just 85, and we've got 1785. So we see how we have this type of problem, and it can allow us to create one that might be a little bit easier to deal with. So let's look at another type of problem that we might come across. Let's say we want to multiply something by, let's say 98. Well, what would be a good way to do that? Well, 98's pretty close to 100. So 98 equals 100 minus 2. So since they're equal to each other, I can use 100 minus 2 in place of 98. And maybe that would make things a little bit easier. Certainly multiplying by 100 is pretty easy. Multiplying by 2 is, I think, pretty easy. So let's see. Let's try, here we go, 52 times 98. And what is that going to equal? Well, if we use this, it's going to be 52 times 100 minus 2, because that's equal to 98. I just did a substitution, and going to just stick 2 zeros on that. That's 5200 minus, well, 2 times that is 2 times 2 is 4, 104. And here we go is 5,096. Answer. So that's just a real quick about why we might want to use the distributive property, how you might already be using it, and ways you can set up problems using it. Now let's carry on with the lesson itself. Okay, this is 2-1, the distributive property and removing parentheses. This is a great technique, especially for doing mental math, and I'll show you a couple of those as we move along. You do want to read through the lesson, pay attention to the properties that are given, the distributive property of multiplication over addition, and also the distributive property of multiplication over subtraction. Now, we know that we can change addition to subtraction, or subtraction to addition, but it's good to know that the distributive property works for either one of them. We've got a couple of examples in here. You want to read through them and take a look at it. And why don't you go ahead and do that? I'll wait right here. You can pause this, and when you come back, we'll take a look at the guided example that's on the next page. Hey, that was quick. I hope you got good notes on that. We'll be looking at them. So your guided example, this is on page 68, example 3. And this asks you to expand 2x times, in parentheses, 5x minus 3. We want to use the distributive property for this. And this is important algebraically because we can't add 5x and negative 3 or minus 3. Because 5x's minus 3 units doesn't make any sense. I don't know how many x's are in there. That's just a kind of an unknown quantity until I can define x. And so the distributive property gives us a way to rearrange a problem and work around the orders of operation. So it's a shortcut. So what's going to happen here? So 2x times 5x minus 3. What's going to go into the first block there? We have our 2x times 5x minus 3. And this equals 2x times what? Well, this gets distributed over everything in here, so the first thing it's going to get distributed to right here is going to be 5x. So 2x times 5x, and that's going to be minus the second thing it gets distributed to is over here, and that'll be 2x times minus 3, so minus 2 times 3 is 6, so minus 2x times 3. I'm going to line up my equal signs. 2 times 5 is 10. X times x is x squared. Minus 2 times 3 is 6. And x is just x. So I now have the expansion of this particular problem. And it gives me that it's 10x squared minus 6x. Okay, let's take a look at some guided examples for lesson 2-1. I'm going to go ahead and run through these. Again, these are not in the book. You have examples in the book that are similar. You can look at those. Those are good examples of how to show your work related to this kind of math. These should be in your notebook. Okay, let's take a look at this first one. You can read through this and get to what the question is. This is pretty typical of a lot of kind of real-world problems. You get things that are presented and you don't really know everything, but you might want to be able to write it up as an expression that you could evaluate later. So we've got this first one that shows that Michael earns 7, and then in parentheses, x plus 2y plus z, close parentheses, dollars each week. All they're asking you to do here, and after all this language, is use the distributive property to give an expression that is equivalent to 7, open parentheses, x plus 2y plus z, close parentheses. And so what we're going to use is our distributive property of multiplication over addition, because this is, after all, an addition problem. So we'll use the distributive property that tells us that 7 times x plus 2y plus z is equal to, that's what equivalent means, is equal to 7x plus 2 times 7 is 14. That's 14y plus just 1z. 1 times 7 is 7, so is 7z. And we've done this. The guided example is done. So even though there are more terms, more than the 2 that are shown in the statement of the property, because it's in parentheses, we can distribute this 7 and multiply it times every term inside of this equation, this expression. We now have an equation where we've set these two equal, and the distributive property of multiplication over addition allows us to do that. Okay, make sure that's in your notes. If you need to pause this, please do, and then come back and we'll get on to the next one. Okay, here's our next example, and this is an expansion. You can already tell me which distributive property this is. This is a subtraction problem, and we've got right here, this is subtraction. I don't know what that is. Little subtraction problem. This is a -3, so -3 minus 2t, and it's being multiplied by a -7. So if we were to expand that, we have a -7 times a -3 minus 2t. You notice I put a little tail on my t. That's to make sure that I don't confuse it with a plus sign. In this context I wouldn't, but in other situations I might. So a good idea to be careful about how you write your letters to make sure they don't confuse you. So first I'm going to multiply the 7 times -7 times a -3, and so that's going to give me negative times a negative is a positive, so that'll give me 21. And then the second thing I'm going to do is going to multiply -7 times a minus 2t, and that's going to be minus -7 times 2 is a -14t. This is an operation sign. That's a subtraction sign. This is the negative sign. So this is minus a positive 2t. Now I'm multiplying it by a -7. I have a -14t. I don't want to leave it like this. A negative is a positive. So 21 plus 14. T is our expansion. And circle your answers when you're done, please. Okay, again, make notes of this, get it in your notes, pause if you need to, then join me on the next problem. Okay, we've got another expansion. This is like the guided example, so I'm pretty sure you could just work right through this real quickly. The difference here is that there's a variable in the term being multiplied times everything else in the problem. Still, it's the distributive property, doesn't matter to us. We've got 3x times 2x minus 6. So this is the distributive property of multiplication over subtraction. 3x times 2x, 3 times 2 is 6, x times x is x squared. So 3x times 2x is 6x squared, minus 3 times 6 is 18x. So 3x times minus 6 would be minus 18x. And we are done. Easy. Done with this one. Make notes. Let's get to the next. Okay, here's another example to add to your notes. And I want to ask you to try this real quick, is simplify this expression. -12, and then in parentheses, times 1/3 plus 3/4. Pause the video, go ahead and work on it yourself for a second, and then come on back, and I'll be waiting here for you. Okay. Hey, welcome back. Not sure what you did to solve it. This is a case where using the distributive property can really help us. If you decided to add these two fractions together first and then multiply it times a negative 12, you probably made your life a little bit more difficult than you needed to, because you had to get a common factor and then you added them together, and a lot of work. If instead we use the distributive property to over addition, we would get to a negative 12 times 1/3 would be a negative 12 over 3, plus a negative 12 times 3/4 is going to be, and I'm going to write this as a multiplication, a negative 12 times 3 over 4. The reason I did this right here in this case is because I wanted to be able to simplify this. Well, I know 3 goes into a negative 12, that goes in a negative 4 times. Here I can factor 4 into negative 12. 4 goes into a negative 12, a negative 3 times 3. The denominators are now gone, so that's a negative 4 plus a negative 9, and that all equals, let's see, 4 minus 9, oh, plus a negative 9, so that's going to be a negative 13. Cool, I have an answer. Again, put this into your notes. This is a great example of how the distributive property can really help to make some math a lot simpler, and I'll give you a way to be able to just do it and perhaps even do it in your head. Okay, take your notes, come on back, and we'll continue with the next one. This next one, I'm asking you to use the distributive property to write 30 plus 2x as the sum of two fractions. Now, remember that the fraction bar is a grouping symbol, and as such, it's as powerful as parentheses, and so in fact, this really represents a distributive property type of problem. And let me rewrite it in a way that might make it a little bit easier to see, and I'm going to write that as 1 over 10 times 30 plus 2x. This is making use of the distributive property, and to show me that what this is up here, this one right here, is the same as this one right here. These represent the same problem represented different ways, and now I can see pretty clearly how I could represent this as the sum of two fractions. 1/10 times 30 is going to be 30 over 10. 1/10 times 2x is going to be 2x over 10. So I've got 30 over 10, 2x over 10. We're not done yet. Even though we've represented it as the sum of two fractions, we need to simplify our fractions and put them into simplest terms. Well, 10 goes into 30 3 times, so that's simple. And 2 and 10 are common. 2 goes into 2 1 time, so I just have x. And 2 goes into 10 5 times. I have 5. This is my answer. What you see here is the work that you need to do when you're showing your work for a distributive property problem.